Today, we will be integrating the value of cosecant to the power 9 of x. First up, let us identify whether our exponent here is an odd or even. 9 here is an odd number, which means whenever we are dealing with an integral of cosecant with an odd exponent, we would first need to factor out 1 cosecant squared of x, making this the integral of cosecant power of 7 of x multiplied by the factored out cosecant squared of x. And what's left here would be the dx, so just bring it down. And the difference between whether the exponent is an odd or even, when we have an odd exponent, we would then need to use integration by parts. And this is where we need to have the factor that cosecant squared of x, because we will be combining this with the dx, which will be on the dv, and u here would be cosecant to the power 7 of x. And according to our formula for integration by parts, the integral of u multiplied by the derivative of v or dv would be equal to u multiplied by v minus the integral of v multiplied by the derivative of u. In our case, we already have u and dv in here, in which case what we need here would be the v and the derivative of u. Firstly, u here in this case would be cosecant to the power 7 of x. Take the derivative of this. Since it has an exponent, let us use chain rule, focusing on the outer function or the power of 7. Bring this down according to the power rule of derivative. 7 multiplied by the inner function, which is cosecant to the power of 7 minus 1 would be 6 of x. And after that, multiply this by the derivative of the inner function. The derivative of cosecant of x would be equal to negative cosecant of x multiplied by cotangent of x. We can simplify this by combining the cosecant, making du in here be negative 7 because it has a negative there. Cosecant to the power 6 multiplied by cosecant would be cosecant to the power 7 of x, and multiply this by cotangent of x. So this would be our full du value. And for dv, what we need here would be the v. And for this one, in order to get the v value, it would be the opposite of derivative, which is integration. Taking the integral of cosecant squared of x, it would actually be equal to negative cotangent of x. Just a reminder, the derivative of cotangent of x would be equal to negative cosecant squared of x. And since the opposite of a derivative is an integral, the integral of negative cosecant squared of x would be cotangent of x. But since what we have here would be a positive cosecant squared of x, our integral would be a negative cotangent of x. After that, let us just plug in our values. First up would be the multiply or u multiplied by v. U here in this case would be cosecant to the power 7 of x, and v here would be equal to negative cotangent of x. We can actually put the negative sign on the front, making this a negative cosecant power of 7 of x multiplied by cotangent of x, minus the integral of v in this case would be negative cotangent of x, and du right here would be this one. Let me just erase this. It would be negative 7 cosecant to the power 7 of x, cotangent of x. Alright, and I forgot, whenever you're taking a derivative, always multiply it by dx, since it is respect to x. So this would be dx. Next up would be to simplify this integral expression. No need to pay attention to this first part because it is already been simplified. And for this one, you can see here that both here had negative sign, so it would be a positive value in here. We have cotangent of x and cotangent of x. Multiplying these two together, it would be cotangent squared of x. And what's left here would be, wait, I forgot, we have a 7 here. We can actually put 7 outside the integral since it is a coefficient. And what we have left here would be cosecant to the power 7 of x and the dx. After simplifying this integral expression, what we need to do here next would be to make sure that there will be only one trigonometric value in here. You cannot have a cotangent and a cosecant at the same time in order to solve an integral. So what we are going to do here would be to convert one to the other by doing so with a trigonometric identity. Now, for the relationship of trigonometric identity between a cotangent and cosecant, what we have here would be cosecant squared of x be equal to cotangent squared of x plus 1. Now, first, you must ask yourself, which is better to substitute in here? Would it be the cotangent squared of x or the cosecant squared of x? Let us try first cosecant squared of x. Cosecant squared of x here, we can substitute it. But since what we have here is a cosecant to the power 7 of x, 7 here is an odd number, but the exponent in here is an even number, so you cannot do it. And instead, we can do substitution on cotangent squared of x in here. You can just put 1 to the other side, making this cotangent squared of x be equal to cosecant squared of x minus 1. And thus, we can substitute cotangent squared of x as this one. So this should be the substituted cosecant squared of x minus 1 and copy the rest. And after that, you can distribute this one among the parentheses. Multiplying these two together would result you with cosecant to the power 9 of x, and multiplying these two would be a negative cosecant to the power 7 of x of dx. And what we need to do here next would be to split the integral into two parts, splitting these two together. For this one, negative 7, integral of this first part, and multiplying this by dx. And for the second part, you can see here that negative 7 multiplied by a negative here would result in a positive sign, which makes this plus 7 integral of cosecant to the power 7 of x, which is the second part, and also multiply it by dx. And after that, you should have a value of something like this. And you can see here, we had our original problem as with this one. We have the integral of cosecant to the power 9 of x, and also in here. So we need to get rid of this one. And you shall recall that this integral right here is equal to this value right here. We had just modified it. And we can equate that to each other. this should be equal to this one. And now we need to get rid of this one. We had here a negative 7. So we need to add plus 7 integral of this value right here, the exact same value, to both sides. So for this one, 1 plus 7 would be 8. Integral of our original problem be equal to, bring this down first. And for this one, it would be equal to 0. And what you have left here would be this one. So just bring it down again. And you are left with this equation now. Since in our problem, we only need one integral of cosecant to the power 9 of x, we need to divide both sides by 8 in order to get rid of this. And for this one, the 8 would be cancelled out and you are left with our original problem. This should be equal to, for this one, we can put this as negative 1 over 8 multiplied by cosecant to the power 7 of x, cotangent of x. Plus, for this one, it would be 7 over 8 integral of cosecant to the power 7 of x of dx. Now we are nearing the end. As I had said earlier, for the first part, it has already been simplified, so no need to pay attention to that. And let's just put attention on the second part. You can see here, we had an integral of cosecant to the power of 7 of x. It is similar to our original problem because it is also an integral of cosecant, and both here has an odd exponent. So you can just repeat the same step that we had did earlier by factoring out cosecant squared of x and integrating it by parts, and you will arrive at an answer. But in this video, I will not be explaining because I had already been covered it in my previous video. So I will just be putting the full answer that I had gotten on that video. So for this one, the integral of cosecant to the power 7 of x of dx, it would be equal to negative 1/6 of cosecant to the power of 5 of x, cotangent of x, minus 5 over 24 cosecant to the power 3 of x, cotangent of x, minus 5 over 16. Wait, let me just put it in here. Cosecant of x, cotangent of x, plus 5 over 16 natural log of the absolute value of cosecant of x minus cotangent of x plus c. This was the full value of the integral of cosecant to the power 7 of x that I had solved in my video. So we will just be substituting it into this one right here in order to get our answer. So for our answer in here, it would be equal to this one. Plus 7 over 8. And let's put a bracket which represents the value of the integral of this, which is this one. So this would be your full value of it. And now, for your final answer, you just need to multiply 7 over 8 among all the coefficients inside the bracket. The final answer for the integral of cosecant to the power 9 of x would be equal to negative 1/8 cosecant to the power 7 of x cotangent of x plus 7 over 8 multiplied by 1/6 would be equal to negative 7 over 48. Multiplying 7 over 8 by this one, it would be equal to negative 35 over 192. Remember this is multiplied by 7 over 8. Multiplying this by negative 5 over 16 would be equal to negative 35 over 128. Multiplying 7 over 8 by 5 over 16 again, it would be equal to positive 35 over 128. Natural log of this one plus the constant of integration. This would be your final value.